Hi everyone. Here we are. We're going to do the last section of 2018, 4.4 factoring. But first, we're going to do a little bit review from Algebra 1 factoring. Okay, so we're going to start. There's actually a process, and you have to do it in this order. First thing you're going to always check is there is a greatest common factor. Once you check that, you check to see if it's a binomial or a trinomial. If it's a binomial, you're going to check to see if it's a dots problem, a difference of two squares. If it's a trinomial, you're going to check to see if it's a perfect square trinomial, and if it's not, it could just be a normal diamond problem. And I'm going to do some problems in just a minute to show you. Okay, so we're going to start with the greatest common factor. I'm doing Monitoring Progress 1 from section 4.4 on page 180. So, what is the greatest common factor in each of these terms?
X.
Perfect. So we're going to factor it out, which means we actually divide it out. So I have an x there, and when we divide this out, we have x squared minus 7x plus 10. But we're not done, because we have a trinomial here, and I'm skipping ahead, but we have to see if we can continue to factor it. With the trinomials, you're going to use the diamond method. So I'm going to put -7 here, which is the B. I'm going to put 10 here, which is the C. Now, what two numbers do I multiply to get positive 10, but when I add them, I get -7?
-5 and -2.
Perfect. So then we continue to factor it. We draw what I like to call double bubble, and I'm going to write x minus 5 and x minus 2. This is the fully factored form of this problem. All right, Monitoring Progress 3. What is the greatest common factor in each of these terms?
8m to the third.
Perfect. Okay, 8m to the fifth divided by 8m to the third, m squared, minus 2m plus 8m cubed divided by 8m cubed makes 1. So now we're going to look at this one, and we're going to think, oh, is this a diamond problem, or is it a perfect square trinomial? Well, is this one a square? Yes. Is this one a square? Yes. When I multiply them together, squeeze them together, and I double it, will it make 2 in the middle? Yes. So it's a perfect square trinomial. And again, we're jumping ahead, but it's m minus 1 quantity squared. Okay, after you figure out the greatest common factor, if there is one, you're going to look to see if it's a binomial. So if it's a binomial, such as this one, you're going to think, is this a special one that's called a difference of two squares, or we like to call it dots? Is this a square? Yes, it is. X times x. Is this a square? Yes, it is. 4 times 4. Is this a difference sign or subtraction? Yes, it is. Perfect. So it's a dots problem. So you double bubble, you put x's here, you put 4's here, and your signs are going to be plus and minus. Okay, so here's another problem called a perfect square trinomial. We have done this one for multiplication. We're going to do this now for division, or the factoring portion of it. Is there a greatest common factor I could take out? No, there isn't. Is it a binomial or a dots problem? No, it's not. So it's a trinomial. Is this a square? Yes. Is this a square? Yes. If I squeeze them together, 1p, and I double it, does it make 2p? Yes. And that has to be a subtraction and a plus. So that means it's a perfect square trinomial, which looks like p minus 1 quantity squared. Now, I'm going to add a problem. Let's say that this problem was x squared plus 4x plus 4. This is also a perfect square trinomial. Is this a square? Yes. Is this a square? Yes. if I squeeze them together to make 2x, and I multiply it by 2, do I get the middle term? Yes. So this is also a perfect square trinomial, but it's x plus 2 quantity squared. Now let's move on to the trinomials, or some people called it the diamond method. Is there a greatest common factor? No. Is it a binomial or dots problem? No. Is it a perfect square trinomial? Is that a square? Yes. Is that a square? No. All right, let's try it with the diamond method. We're going to put the 7 here and the 10 here. What two numbers do I multiply to get 10, but when I add them, I get 7, 2, and 5. Perfect. So then I double bubble, and I write x plus 2 and x plus 5. Now the last one has to do with if there is a number, the coefficient, in the leading coefficient, if it's greater than 1. So here's how we're going to do this. We're going to take this number, we're going to multiply it with c. This b is going to stay the same. It's going to be 7. This number down here, it's not going to be 5, but it's going to be 5 times 2, which is 10. Oh, look, it's the same numbers, 2 and 5. However, since I multiplied it over, I have to bring it back and I have to divide it back out. So I take this 2 and I divide each of these terms by 2. Now, if I can reduce it, reduce it. So that becomes a 1. If I can't reduce it, it looks like this, and I think you heard me once before call it a shove it problem, or you scoot it in front. I'm going to double bubble. This one becomes x plus 1. But this one, I take the 2 and I put it as the first coefficient plus 5. And that's my answer.